Our next lesson is called Graphing in Standard Form. So I pose you with this question. Is there another way to graph a linear equation in two variables other than using a table of values or slope-intercept form? Now remember, slope-intercept form is y equals mx plus b. So here you're looking at the answer to that question, which is what's called standard form. Standard form keeps the variables on the same side together. Now, A and B are considered to be coefficients, and C is going to be a constant. Okay, all of those are numbers. The X and the Y are variables, and they are going to stay variables. So examples of linear equations given in standard form might be something like 2x plus 7y equals 102. Or 3x minus y equals 27, okay? And I could come up with more and more and more examples. But you're gonna notice the variables are together on the same side with the constant c on the other side. So how can you graph these equations without changing the equation into y equals mx plus b form? Because of course that's always an option, which we learned in previous lesson. You can graph them using intercepts. So it's important to understand what an intercept looks like in order to use this method. X and y intercepts are the points where the line touches the x or y axis. So if it's a y-intercept right here, and you are on the y-axis, that means your x value is a 0. So 0, y is the setup for a y-intercept. Whereas if you're an x-intercept, and you're on the x-axis, your y value is a 0. So your setup is x comma 0. X can be anything, but the y will always be 0. We're going to use that information to graph using intercepts so that we can leave the equation in standard form. So in example 1, graph the line 2x plus 4y equals 8 using the x and y intercepts of the graph. So I'm going to split the page in half here so that we can find one intercept on each side. We'll start with the x-intercept, which remember means that my y value is a 0. So I will start by writing the equation 2x plus 4y equals 8. And I'm going to use y equals 0 as my value for y to start simplifying this equation and then eventually solving. So I'll have 2x plus 4 times 0 equals 8. That means I really just have 2x, 4 times 0 is 0, wipes it out, equals 8. And now I can solve for x by dividing each side by 2 and seeing that x is 4. So now I know my x value of the coordinate is a 4. My y value was a 0 because it's an x-intercept. And I have the first point that I will plot on my graph. So here's the x-axis, the y-axis. 4, 0 would be located right there. Now likewise, for my y-intercept, remember this is when your x value is 0. So we'll rewrite the original equation just like we did on the other side. But this time we will replace the x with a 0. So 2 times 0 is 0, and we have 4y equals 8. And then we can get y alone by dividing both sides by 4. So y equals 2. So now I know the coordinate is 0 for my x value since it's a y-intercept and 2 for my y value. So now I'll go to the graph and I'll plot 0, 2. I only need 2 points to make a line. And now with a straight edge ruler, you can connect these two. Make sure you have your arrows on your ends, and then you're going to label it with the original equation. And you have successfully graphed, keeping the equation in standard form. Now, as a follow-up to this question, what is the slope of the line 2x plus 4y equals 8? And how does it relate to the equation in standard form? So if we look at the slope up above by using the 2 points we have, and we use rise over run, we see that we went down 2 and to the right 4. So down 2 would be negative 2. To the right 4 would be a positive 4. That simplifies to negative 1/2. Now, if we look at our equation in standard form, we can get that same value by using the formula negative a over b. So remember, standard form is ax plus by equals c. So the a value is in front of x, that's a 2. So this is going to be negative, and then a 2 on top. The b value is a 4, and that also simplifies to negative 1/2. So there is a way that you can find the slope from standard form. The formula is negative a over b, and you just plug the values in. Now for example 2, we're going to look at a word problem that involves standard form. Emily received a gift card for her birthday and decided to download a few books. She downloaded a few $6 books and a few $3 books. She spent $30 on books. Let X represent the number of $6 books and Y represent the number of $3 books. Write an equation to represent the situation. Graph the equation using the X and Y intercepts. So typically I would say to you, we need a let statement. However, they have given it to us right there. So we know X is the $6 books and Y are the $3 books. So when you're writing an equation like this, you need to think about what you're doing. If X is the number of $6 books, no matter how many of them you buy, you need to multiply them by $6. So if you bought 2 books, it'd be $12. If you bought 10 of those books, it'd be $60. You're multiplying 6 by the number of books that you buy. Similarly, for the $3 books, it's $3 for each book you buy, for a total of $30. So now we can use the same method as we did before. We'll find our x-intercept. We'll find our y-intercept. Now remember, if it's the x-intercept, that means y is 0. So in our equation, 6x plus 3y equals 30, I'm going to replace y with 0. 6x, 3 times 0 is 0. So 6x equals 30. I would divide both sides by 6 and see that x is 5. So my coordinate is going to be 5, 0. For the y-intercept, I'm going to use an x value of 0. So I'll write my original equation, 6x plus 3y equals 30. This time I'm replacing x with a 0. 6 times 0 is 0, which leaves me with 3y equals 30. I would divide by 3 and see that y equals 10. So 0, 10 is my coordinate. So now when creating the graph, I'm going to title it Book Rentals, because that is what our problem is about. And you can see I already have a scale. Every little block is going by 1. Now, X was supposed to represent the number of $6 books. So this is my X-axis. I'm going to label it with number of $6 books. On my Y-axis, I have number of $3 books. And now I can plot my points. You should have 0, 10, which is up here on the Y-axis, and 5, 0. Like so. Now, typically we would go ahead and create a line for this, but we have to think about whether it makes sense to connect these. If I connect them, that implies that I can buy 1.5 books, and we know that doesn't make any sense. So what you'd want to do is put your ruler down and only plot the points that actually fall on the grid marks. So if you were to do that, it would look like this. And we're going to leave them unconnected because there are no values between the coordinates. You can only buy a whole number of books, which is, again, why we're only in the first quadrant, as you can see, because it doesn't make sense to have negatives either. Okay, so we're going to leave it like this because there are no values in between the points. So now if we look at the question, if Emily downloaded 3 $6 books, how many $3 books did she download? It specifically says you have to use the graph. So we cannot use our equation and do some algebra and figure that out at this phase. We want to just look at the graph. So if I go up and find 3 $6 books, that'd be here. I'm going to follow it up and then follow it over to the y-axis and see that that would be 4. So Emily can purchase 4 $3 books. And it says use the graph to justify your answer. So I'm able to do that because I can find the point 3, 4 on the graph. So I'm using the graph only to explain why I'm getting what I'm getting. That's different than the next question where it says verify your answer from the previous question algebraically. So if they're saying 3 $6 books, that means my X value is a 3, and I'm claiming you can buy 4 $3 books, so my Y value is a 4. So I'm checking the coordinate 3, 4 in my equation. 6x plus 3y equals 30. Replace my x with a 3 and my y with a 4. This would be 18 plus 12, and that indeed does equal 30. So now I verified it algebraically, and you can see the difference between those two questions. And that concludes your lesson on graphing in standard form.